So now you have some functions created for different elements using different methods, and at least have a basic idea of how that works. You probably want to use this for either estimating some values, average grades, and those sorts of things. So we have a number of options here. Well, not that many, but we do have different pathways. So first of all, I'll take the simplest approach, where you want to convert this into a volume that you can check out. So you've created this function and you want to use this function to evaluate on the grid. So for that we create an empty model, which is basically an empty grid, and we can evaluate with a function on this. So let's connect these two together. So the create empty model option, if you double click on it, it gives you a grid cell size, and it will just fill up your modeling space with a grid where we can evaluate your functions on. So I'll just leave this to the extent that we've set up. So here, okay, let's make it a little bit more interesting. So just reduce the base grid size to 25 meters, okay. And then we double click on evaluate grid with function, and now you see that you have functions that you have over here. They're listed in the list here as well. So now you can select, for example, the RBF for the copper and the machine learning for the copper. Oh, might as well just do the gold ones as well. We'll give it a name, so we estimate. And then we run this one. Take a bit of time, hopefully not that long. No, it should be okay. There we go. We have a grid evaluated with our functions. So instead of just seeing a single shell, you evaluate that function everywhere where you have this blocks or the model extent set up. So now we can go in here. We have different options. We can look at the machine learning copper evaluation, or the copper estimates, the RBF for the gold, or machine learning for the gold. So there's different things here. So let's look at the RBF for a sec. So if we change the cutoff for this one, down on the settings, you see the shape. Let me just turn off that one. The shape. But as you notice, you actually get some tetrahedral blocks, as it were. So you can actually start playing with that as well. So you can change the cutoff dynamically here on these blocks. And what it does, if you go to the info tab here, so you get an estimate of the volume and the average grade at that setting. So here the average grade is 1.2 almost. So if I change this back to cutoff range of 0, almost everything, you can see that the mean estimated value is dropping down to 0.5. So that way you can get a quick idea of the volume for this function. Likewise, you can then go and say, okay, let's do the machine learning regression 1 at a cutoff of 1. You can see the mean average grade is roughly the same. The volume is a bit different though. So that way you can compare different methods and get these volume estimates quite quickly. But in many cases, just doing it on a regular grid is probably not what you're after. Often you want to combine that with some geological model. So in this case, we have a model. Here's a quartz porphyry zone, oxidation layer at the top. Well, let me just focus on the quartz porphyry here. So we just turn off. Unknown is not there, but so now we have this quartz porphyry zone, and let's say that we're interested in evaluating that one. So we do roughly the same procedure, but before we do that, there's a drop down here that's quite important for this. So here it says all data, which assumes that all the data in your original data object on your project tree is going to be used for evaluations or processing. But there's also an option to drop down to only visible data. So that gives you a bit of a warning if you have existing workflows. We don't care here because we're setting up a new workflow anyway. So we now drag in the model that we built. But the model only has the quartz porphyry visible. So if you now do the same thing by evaluating on this model, eval QZP, so we can select again the RBS and the machine learning functions, and we run this one. So now we get the estimations of these functions just on the quartz porphyry. If you would have set this to all data, it would have been pretty much the same as the previous one. It would just fill the whole space with the evaluation. But now it's only evaluated exactly on the model, on the domain in the model that we've highlighted. So if you have multiple domains visible in 3D, it means that they will all get evaluated. But here we just have the quartz porphyry, so we can actually start highlighting, in this case, the RBF copper grade within the quartz porphyry. And of course, then we can get a volume and an estimated average grade within that. So we can do that for all different sorts of domains. You can do all the different elements, different methods. So you can do that with an RBF, you can do that with machine learning methods, and they all get evaluated on those grids, and then you can switch between them and adjust your thresholds or your cutoffs. But there's also another way you can actually use this in your processing, and that's actually in your model descriptors. So we've shown how in a different video how you can build geological models with the model descriptor, but we can also do that for numeric data. So this would more or less create a grade shell. So let's give it a name, grade model. Okay, so here, just like we do with geological modeling, we can select one of the functions. I'm going to select the machine learning copper one. Let's leave the resolution the same. But now this is going to be an important aspect. So instead of having the default threshold at 0, which you're using for classification, because you're classifying between plus and minus 1, so the threshold is at 0, we're actually going to change this setting to the cutoff threshold. So here I want to set it to 1. Click OK, and I'll run this one with the default. And then it's going to be processing for a bit. I might just pause the video until it's finished. It'll take a little bit longer. Right, so now it's done processing, and what you see now is something slightly different. But now you'll actually have your copper ml at 1 grams per ton as a grade shell, basically. I mean, it's still in the volume. But you can then export this by extracting the outside of this volume as a triangulated solid. We can actually start looking at this and see that it's represented a little bit like a solid this way, but also it should give us a volume. The thing you don't have anymore is the mean grade, so we could actually evaluate this one with the function itself again, which would give us a grade. But this way you can then export it as a solid, as a DXF if you want to. But also you can start doing other things with these functions now, because you sort of defined this volume where you evaluated everything to be above 1 gram per ton. But maybe what you're interested in is to know the size of the quartz porphyry zone within this. So actually reversing what we did before. So let's hit OK. So we can actually go to the model descriptor here. And we can start adding a subdomain. So instead of this, we'll actually say we actually want to model within the zone that we've just defined, or the domain. And in this case, we want to have the quartz porphyry function using the same resolution settings, but now we're using geological modeling, so we don't need to change the threshold. And we'll leave everything as it is and press OK. And we'll rerun this one. The same resolution, so now it's going to be processing again, so I'll stop the video until it's finished. Okay, that's done now. So let's go back here. So let's turn off the previous one that we had. Now we can remove the unknowns. So now we can see that within the 1 gram per ton grade shell, as it were, you can see where the quartz porphyry intersects. We can do that one more step further. So sorry, on the descriptors. So let's also include the granodiorite here. So we still have to select the grade shell in here, then select the granodiorite function, same resolution again. And let's also do this on the outside here. So the outside is AVT, and we press OK. Right, so now we'll rerun this one again with everything that we have in our model here at the same resolution. Once it's done, you'll see that there's also a little bit of granodiorite here and an AVT, and I'll show you the results when it's done processing. Alright, so that's finished now as well. I'll go back to the data tab, turn off the previous model again. So now I'll remove everything on the outside. Now we have 3 zones within our 1 gram per ton grade shell. We have a slightly pinkish, sorry for the color, AVT, the purplish quartz porphyry, and then the dark red purple for the granodiorite. So with this, what we can then do, let's go to select our colors. We'll keep this open here. We can actually get an idea of the percentages. So we know the total volume of the 1 gram per ton grade shell. But let's say turning off the quartz porphyry, or actually everything except the quartz porphyry, you can get a volume estimate. You have to just switch tabs for it to update. But you can have a percentage that way of the quartz porphyry within the 1 grade per ton grade shell. Similarly for the AVT, you can see how much that takes up, and that way you can get an idea of the percentages of the different domains within your grade shell. So if you were to think about mining this 1 gram per ton, you can see what the percentage of the various rock types are that you're expecting to encounter. So you can actually go both ways this way. So there's a lot of flexibility in here, and playing with it and seeing what suits your project that way. Right, thanks for that.